Do you know one of the best tools you have for working safely near electricity?
The electrically safe work condition. The electrically safe work condition is an 8-step process designed to eliminate electrical hazards in line with the hierarchy of risk controls. Completely removing the hazard should always be your primary goal.
It's important to understand that every time you needlessly subject yourself to a hazardous voltage, you're putting yourself in danger. You might have walked away unharmed before, but it only takes one moment for a serious injury or death to occur. Every time you work disregarding safety, you increase your risk of injury or fatality.
So what makes an electrically safe work condition? The NFPA 70E defines it as a state in which an electrical conductor or circuit part has been disconnected from energized parts, locked or tagged in accordance with established standards, tested to verify the absence of voltage, and if necessary, temporarily grounded for personnel protection. Establishing an electrically safe work condition to temporarily eliminate electrical hazards is the only security that you, as the qualified worker, have to ensure your own safety.
Only qualified individuals are allowed to oversee the creation of an electrically safe work condition. If you are not qualified, or if you're unfamiliar with the hazards and construction of equipment in your facility, you must include a qualified person in the electrically safe work condition process. Creating an electrically safe work condition calls for caution and diligence every time. No matter how often you've done it, always carefully take each step as if you're doing it for the first time.
With that in mind, how do we create an electrically safe work condition? The NFPA 70E outlines how to produce an electrically safe work condition in Article 120. Documentation is critical and a checklist is required all the way through the electrically safe work condition process. Take a look at this page number below to see a sample process document and a checklist. Remember that many of these steps require you to wear arc flash and electrical shock PPE. There's a lot of information to digest here, but on this page, you can find an easy way to remember the process using the acronym LOCK squared TAG. Let's go through the steps now.
L is for locate. The first step in setting up an ESWC is to locate all possible sources of electrical energy. This can be a lot more challenging than it sounds. Generally, the simplest way is to begin with the schematics that identify the switches and protected devices that feed the work area. You'll often find schematics are missing or out of date, so make sure to verify that the schematics are current and easily accessible. Also, verify that the identification tags for sources and feeds on your electrical equipment are present and up to date. These can be a valuable resource. An alternative method is to locate electrical feeds, is to collaborate with workers who routinely service the equipment. Changes might have been made without their knowledge, so work with them to make sure records are up to date. In a lot of cases, electrical equipment has a single source of power, but sometimes equipment is dual fed. This is most common when there are emergency generators, double-ended subs, and parallel feeds.
Parallel feeds are typically present in facilities with mission-critical equipment, like military bases, wastewater treatment facilities, prisons, ethanol plants, and hospitals. Some equipment is purposefully designed to have control voltage fed from a different source than the equipment itself. Ideally, this will be noted on the equipment panels, but when following safe work practices, you should never rely on labeling alone.
You also need to be aware of backfeeds when you're looking for potential sources of power. This means you're identifying more than sources on the line side. Backfeeds are power sources on the load side, so always check the load side too. Isolate yourself from temporary power sources like capacitor banks and mobile generators that are used during shutdowns or equipment maintenance.
Step 5 in the electrically safe work condition process involves releasing mechanical energy. Before opening switches where mechanical energy may be present, relieve the mechanical energy by operating the equipment prior to de-energizing. For example, if you have a long downhill conveyor with debris on it, run the debris off the conveyor before shutting down the equipment. The conveyor may still need to be secured, but this will help reduce the likelihood of accidental potential energization and save you the trouble of re-energizing the circuit. In this step, you should verify that the equipment is operating as intended. And finally, make sure you're aware of any planned outages. That's our L for locate. Now on to the O.
The O stands for open. After you've located all possible sources of electrical energy, open all disconnects for each feed. This step requires wearing PPE. There are a few things you need to think about before taking this step.
1. Communicate. Why is it so important to communicate prior to shutdown? Because if operations staff and leads aren't given sufficient notification, they might lose production time or try to re-energize the equipment. Communication is especially critical where automated equipment like welders and laser cutters are in operation, and shutting down in the middle of the process can be costly.
Number 2, interrupt load circuits. Shut down any equipment operating on the load side of the disconnect. By turning off all loads, the device you're operating will interrupt less current during opening. Operating load switches with as little current as possible is especially important once work is completed and the circuit is set to be re-energized. Opening and closing devices under load makes it more dangerous and increases the likelihood of failure. As part of the NFPA 70E 2021 update, the first operation of a device after maintenance has been added to Table 130.5C as a condition in which an increased likelihood of arc flash incident exists.
3. Operate equipment. The best practice for operating equipment is to wear the recommended arc flash PPE, stand to the side of the equipment, take a deep breath, then flip the switch. You'll find an exception to this principle in 70E. Arc flash PPE may not be required if the equipment has been properly installed and maintained, the doors on and covers closed, and no sign of imminent failure. Given the time it takes to verify proper maintenance and installation, and since it's hard to know what's behind the door, ESWC's policy is to suit up whenever operating equipment. Suiting up in this step makes sense because the next step requires shock and arc flash PPE.
Next, check if the equipment is rated to interrupt the available fault and full load current. In the field, we often see a breaker used in daily operations instead of switches. Breakers and switches can be designed differently, and there's a variation in the number of expected operational cycles. Always look for the safest protective device when operating equipment. Newer equipment, or equipment downstream from newer or smaller / fast-acting protective devices, is generally safer than older equipment that takes longer to open. Remote push-button disconnecting is also recommended for limiting exposure to hazards when operating equipment. That's our O. Now on to the C.
The C stands for check. Check that the disconnecting device is fully open or drawn out. Again, this requires shock and arc flash PPE. When possible, visual verification during this step is required since breakers and switches may sometimes fail to open on all phases. Watch for dangerous situations. It might look like equipment is de-energized because it stopped running, but one or more of the phases could still be powered. Wear PPE and verify that contacts are open when you check that the disconnect has functioned correctly. Taking a look at our acronym, Lock Squared Tag, we're ready for S squared.
S stands for stored energy, and it's squared because there are two types of stored energy that need to be released: electrical and mechanical. First, let's look at electrical. Capacitors, batteries, long cable runs, inductors, and other discrete electrical components can store electricity that must be dissipated through safe means. Allow for sufficient discharge time, use proper discharge equipment, and verify that a voltage is not present.
Now on to mechanical energy. Elements like conveyors and presses are generally found on the load side of where you're working and must also be released. Do this by blocking or emptying the equipment. During this step, you should collaborate with the maintenance manager and equipment operators to develop a thorough understanding of the equipment you're working on so you can address all potential hazards. Remember, S² is for both electrical and mechanical stored energy. Up next, T.
T stands for tags. Locks and tags need to be applied to protect devices used for isolation. A lot of focus has been placed on the lockout-tagout process during the 2000s, and most facilities already have a program in place. Comply with your facility's lockout-tagout rules and procedures to ensure safety. Now on to A.
A is for absence of voltage. Make sure to use adequately rated portable test equipment to verify voltage is absent, and always wear shock and arc flash PPE during this step. So how do you know if your test equipment is adequately rated?
Your testing equipment should be rated for the maximum voltage of the equipment you're working on. A common cause of injury is using Category 3 1000 volt rated test equipment on medium voltage. If you're working on medium voltage, such as 4160, 12470, or 138 system, your normal fluke meter will not allow testing to be performed safely. This device is rated Category 3 1000 volt and Category 4 600 volt. A non-contact meter should genuinely be used on greater voltages.
Selecting the proper test instrument design is key, since test instruments are designed differently. Category 1 is identified for use on electronic equipment. Category 2 is identified for use on single-phase receptacle levels at 30 feet from Category 3 or 60 feet from Category 4. Category 3 is designed for use inside distribution, such as feeders or branch circuits. Category 4 is designed for outside and three-phase utility connections. Refer to this illustration on this page for a diagram of test equipment category ratings. Use test equipment in accordance with manufacturer specifications and approved for the task.
A non-contact proximity tester should never be used for absence of voltage testing below 1000 volts. The Wiggy, or death stick, is not a reliable tester for confirming the absence of voltage. These non-contact meters will not work on DC circuits because they are designed to indicate the magnetic field generated from an AC circuit. We will cover this topic as well as visual inspection and repair of equipment in the video on test equipment.
The live-dead live test sequence is a specific procedure for testing for absence of voltage. It verifies the functionality of the test equipment you're using, ensures that your leads are connected properly, and that the device is on the correct setting.
Need a good way to blow a fuse in your meter? Set it up for reading resistance and connect it to an energized circuit. Make sure you've selected the correct function and know whether the circuit is AC or DC. Here's how it works. First, verify the meter is working on a known live energized source. Then test for dead in the area in which you'll be working. When testing for dead, check each phase to phase and check each phase to ground. Lastly, return to the energized source and verify the meter is still working.
There's an exception to portable electronic test equipment when it comes to mounted absence of voltage testers. To be permitted, the device must be permanently installed in accordance with the manufacturer's instructions and be set up to test the circuit at the location where work is performed. It must be listed and labeled for testing of absence of voltage and should test each phase to phase and phase to ground potential. The test device must also be verified on a known energy source before and after testing for absence of voltage. Qualified individuals should take additional care when using and installing these devices. And finally, our last letter in LOC squared tag.
G stands for grounding. Grounding is the final step in creating an electrically safe work condition. Grounds help protect from induced voltages, stored electrical energy, accidental contact with an energized conductor in the circuit, human error during switching, or where other means of re-energization exist.
Make sure that grounds are placed in the worker's location to ensure their safety. Temporary grounding equipment shall be rated for the maximum fault current, clearing time, and mechanical stress. The connection and device itself must produce an impedance low enough to cause immediate operation of upstream protective devices.
Grounding is one of the most underutilized electrical safety tools. Anyone who has experience with temporary ground installation will attest to how cumbersome they can be. Working areas are generally too small for leads, and finding a good non-insulated surface without damaging equipment can be challenging. So, how do we counter that? Include grounding as part of your employer's pre-job planning.
When grounding on a transformer, consider the low voltage side will produce currents with much higher faults, and the protective devices on the line side will not operate slower than if the grounds were placed on the high side of the transformer. If you're working on the transformer, you may need to ground the high and low voltage side depending on the service being performed.
What happens if a circuit becomes re-energized? The grounds can move, flex, or whip, causing possible injury to the worker. So always position equipment grounds between the worker and possible energy source. Take special precautions when using grounds on a DC bus in a battery system. In these areas, introducing a ground conductor where one is lacking can increase exposure to electrical hazards.
Grounding equipment can save your life. Picture two similar motors sitting next to each other. They're fed out of the same MCC, and you've created an electrically safe work condition for motor number 1 many times. Now it's time to work on motor number 2. You lock out the bucket labeled motor number 2, but you didn't know the feed was changed to a different bucket, and someone forgot to change the equipment labeling and update the one-line diagram. Motor number 2 is controlled by a contactor connected to a PLC. So even though you've tested for dead, you have not verified that you've locked out the correct circuit. Halfway through your work, the contactor closes, energizing the circuit. If you didn't properly ground these conductors, you're at risk to become part of the circuit and sustain serious injuries.
Remove the grounds when work is complete. Forgetting to remove the grounds before you re-energize is one of the worst things you can do. So, how do you avoid it? Attach a lock and key to the ground. Then apply the lock to the lockout-tagout equipment. If the key is secured to the grounding cluster, equipment cannot be re-energized without the grounds being present. You also could position the grounds using zip ties so the cabinet doors cannot be closed while still on the equipment.
Any missed step in the electrically safe work condition process can be fatal. Think about LOC squared tag every time you start the electrically safe work condition process. L, locate all possible sources of energy. O, open all required disconnects. C, check the disconnecting devices are fully open or drawn out. S, stored electrical and mechanical energy must be released before moving forward with work. T, tags and locks should be applied to all protective devices for isolation. A, absence of voltage must be verified with properly rated test equipment. G, grounds should be safely applied in the area you're working in.
Maintaining production is never an adequate reason to perform energized work. Always create an electrically safe work condition first, use insulated tools, and wear your PPE.
The last step in this section is the exercise. Go into your facility, find a piece of equipment you continually work on, and create an electrically safe work condition.
You don't need to perform this. Simply document the process as if you were doing it. Return to this section when you're finished to test your knowledge.